When a graph is increasing, we have it from left to right. So the graph, we always look and read a graph from left to right. So an increasing is when the graph is doing what? Going up, right? And decreasing when it's going down. So when the gradient is positive and negative. And there's a point in between. Generally, when it is a function, it doesn't actually have any sharp bends. It's smooth, and therefore that point in between has a gradient of 0. All right, so it's an interesting point. So we've got 3 different things that are happening here. When our gradient function, which is f of x, when that gradient function is greater than 0, what is true? When the gradient function is greater than 0, it's got a positive gradient, right? But that also tells us that as we read the graph from left to right, it is going up, increasing. Good idea. And the opposite. If it's less than 0, it's a negative gradient. And therefore it's decreasing. So that leaves one other option, and that is if it is equal to 0. If it is equal to 0, it's neither increasing or decreasing, so we call it stationary. Guys, shh. It's a place on the graph where it is not increasing or decreasing. And why we use these words will come out later on when we're looking at applications of this stuff. So what sort of merity questions might be related to this? Okay, we might get something that says simply, okay, so on the function y equals blah, 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 is x equals 2 increasing, decreasing, or stationary? What is happening at that point when x equals 2? So all we have to do is differentiate it. Take the power, multiply by it, decrease the power by 1, take the power, get rid of the 8, and then we're saying at x equals 2, y dash equals 12 times 2 squared plus 4 times 2, which is 448, and 8 makes 56, which is greater than 0, so increasing. And again, they could turn it around into the opposite direction sort of question. Very funny, is, but that's right. All right, So I could turn it around like this, asking you to find the values for wherever it happens to be. So what would we do? First of all, in this paper, we would nearly always differentiate and get the gradient function. For decreasing, what do we want to be true? Less than 0. So 2x minus 3 is less than 0 if it's decreasing. So solving this, so it's got to be less than 3 over 2. Any value for x that is less than 3 over 2 will be decreasing, will be on the decreasing side. So if we have a look at this one, if we use our graphical knowledge, and we know that that is equal to minus 2 minus 1, and it's a positive quadratic. So we've got that picture going on. Where is it decreasing? On this side, right? Yeah. And then on that side it's increasing. So it's decreasing up to the turning point. So what is the turning point? Yep. What's the x value?
0.
What's the x value of the turning point? 1.5. 3 over 2. As we just found out. So anything that is less than 3 over 2 is decreasing, has a negative gradient. Right? So that's what you're answering. Happy? Jordan.